I'm going to be talking about Spyder and how we supported it in the long term on the Apple Arcade platform. So let's go. So a brief introduction about what Spyder is. Spyder is a game that Sumo Sheffield developed for the Apple Arcade. It came out in 2023. It basically involves a cute little robotic agent, surprisingly called 008, who goes around solving puzzles and spying to stop the forces of evil. Uh, it came out in 2020 and was a player favorite, has been a player favorite since then. Uh, Sumo Sheffield, like I said, was the leading studio. Sumo India worked during the development on code, on art, on design even for the DLC stuff. And we have been supporting Spyder for Apple Arcade for the past 3 years since it got released in terms of compliance, because Apple Arcade is a demanding platform when it comes to compliance. They have evolving compliance guidelines that needs to be met. So I'm going to be talking more about the compliance and the strategy that we developed for supporting it over long term, because most mobile games actually begin their inning after they are released, right? So how to keep it updated to make sure that you reach new players and keep already existing players happy. So what are going to be the takeaways from this session? There are three of them. So first is, like I said, the requirements for us to support it over a long period. There were many of them, and we had to strategize how to go about it, because it was something that we were doing for the first time. So a lot of brainstorming had to go in. Then the second part is how the strategy was executed, because it is one thing to have a good strategy and another to make sure that it works. And third is what we learned from this, what are some of the best practices that we think can help every Apple Arcade game. So before I go into the next slide, just a little show of hands. Who here has made or is making an Apple game with Unreal? Okay. Any Apple game for that matter, across engine tech? Has anybody tried doing it or is working on it? Cool. How about Apple app development experience? Are there people who here who have developed apps for the Apple ecosystem? Cool, cool. So I'll start by sharing what problems we had. And I'll actually start with the second point that you see on the slide here, that what were the requirements that we had to meet after Spyder was released in the beginning for Apple Arcade. Apple Arcade is a game subscription service that Apple runs. Currently, it has 200 plus games. Spyder is obviously on the list. What it means to be on Apple Arcade is your game should run on iOS devices, iPhones and iPads. It should also run on Mac Minis and iMacs. And it should also work on the Apple TV, both 4K and previous versions. Not just that, it also has to support different input requirements. So on an iPhone, it needs to support touch devices, but it also needs to support Apple certified controllers like the Xbox controller, the PlayStation controller, even the Nimbus controller. And the controller requirement is across all the three platforms. Other thing which is interesting and challenging is the things like leaderboards, game saves, and achievements. They need to be compatible across all these platforms. So, and to add to that, we had hardware requirements coming up, which definitely meant we had to upgrade Unreal Engine to subsequent versions. Case in example was the M1 architecture. So Apple was moving away from Intel processors, making their own processors. And the next submission that we had to make after 2020 needed to be in the universal Mac binary format. Tech for that, in terms of Unreal support, was going to be available only on 4.26. We were on 4.23. And just to complete the three problem sets here, the problems that we had in threes. So it was not just the minis or the Mac architecture that we had to address. Every year there's a new iPhone that comes in. Once in a while you get an iPhone 14 which has something like a dynamic island which breaks everything in terms of the UI, existing UI at least. And then Apple TV are also a candidate for, generational improvement. So you never know when you would get a new Apple TV model. A couple of days ago, Apple also announced Vision OS for their AR headset. So the things can keep coming at you. So these were the three problems on the compliance front that we had. The most important bit for us to make this transition is actually the first point. So we at Sumo had a lot of source changes to Unreal Force, Unreal UE Force engine source. And if we had to upgrade, we had to take those changes along to the next version of Unreal. These changes are in C++, to be clear. And I'll just take a moment to explain why at Sumo we make changes in C++, because as it is, Unreal is a very stable set of tools to make your games without having to make any changes to C++. But why we make changes at Sumo, there are a couple of reasons for that. We have been using Unreal for nearly a decade now. Started with Crackdown 3, then there was, of course, Snake Pass, there was Hood, there was Sackboy, A Big Adventure, Bolt Gun, and the latest one being the Texas Chainsaw Massacre. And these are different games. So you have a multiplayer game, you have a role-playing game, you have an online game. What the perfect analogy that I can think of is having an automotive manufacturing unit. It all centers around the engine. In this case, it is Unreal. Unreal is a very important part of our tech stack. But when you're manufacturing cars, you essentially have to manufacture different models. So it could be an SUV in one case, a sedan in one case, a truck in another case, which means you have to really fine-tune the engine so that you can make the car or the vehicle that you want, which may operate differently, which may function differently. But engine tuning is very important. And modifying it at the source level gives us a lot of finer control, which also contributes to the quality of life of that project. So when you want to support a project, say for 4 years, if you have really finer and very close to the bone control in C++, it becomes a lot easier for you to have that kind of control. So yeah, that is why we have a lot of source code changes at Sumo. And like I said, to keep Spyder afloat for such a long time, we had to make sure that those changes get propagated to the next version. And thirdly, in the set of problems, Apple has really well-established software and compliance constraints. So for example, all the app development that you do with Apple has to go through Xcode. We started supporting Apple when it was Xcode 12, now it is Xcode 14. So that has to be figured in your long-term plans of supporting strategies. And annually, the Apple compliance requirements change. So you need to factor in those also as you upgrade the tech and keep the game running. They could also need, binary that you submit to the Apple Store needs to have certain attributes today, and the attributes could change or more attributes could be added in the coming version. So these were the technical problems that we had. And along with that, there was a very interesting emotional trifecta also, which kind of sealed it for us when we decided to support Spyder long-term support. Spyder came out of an internal game jam at Sumo. So it's very dear to us for that reason. And secondly, like I mentioned, we worked on it, so even more dear. And then the people were loving it, players were loving it. So these three reasons made it even easier for us to decide to go ahead and support Spyder. So what was the strategy in this upgrade and this maintenance cycle? So my talk is going to have Unreal bits, Xcode bits, and obviously game development requires a really stable version control system, version management system. For Sumo, it has always been Perforce, particularly with projects that use Unreal. We find it a really good match. So what strategy that we came up for these upgrades in Perforce, the diagram kind of shows it. You can have different streams in Perforce where you can pull things and merge them. So the top line, there is a staging, I'm not sure if you guys can see it, but the second column in the top row, that is what we have, that is what our target version was. That is where we were going to be on 4.26 ultimately. The one below that is what we called a staging stream. What that means is, so we use Epic's Perfo stream for source as our source version. So we get things from there, bring it to the staging stream, merge down Spyder into it, make sure all conflicts and merges are properly executed, conflicts are resolved and merges are properly executed, and then push it back onto the Perfos repo. That is the one which we are going to use for submissions to Apple. And we had to do this 3 times. So for 4.24, we had a separate stream, for 4.25, a separate one, and another one for 4.26. And it had to be done manually because mostly it was primarily down to the C++ source changes that we had. Like I said, we were doing it for the first time, so we didn't want to rush things through. We didn't want to miss out on any changes that come through different versions in terms of source, in terms of layout. So we wanted to start slow and then pick up speed. So what was the process of this, of implementing this strategy? So like I mentioned, we gathered source from Epic's online mirror, which is like the latest and greatest for that version, merged it with our staging stream that we had. And one thing that really helped us in this is the Epic roadmap. We tracked what stuff was coming in when, and then made sure that our merges followed up on that. So we would know, for example, what comes in 4.24 and what comes in 4.25, and then we could go ahead with the merge accordingly. And these informed calls really helped us in the long run because they ensured that we didn't miss out on any of the stuff that we needed. Second point is more towards compiling and building for Apple Arcade platforms, so iOS, tvOS, macOS. So UE4 has a build graph. What you can do with build graph is you can customize your build process according to the platform that you have in mind. So the scripts of interest in this case are, for example, for iOS, it will be iOS platform.cs or iOS deploy.cs. So coming back to Xcode side of things, the binaries and the project need to have certain attributes which change from project to project and which are not all covered in the vanilla UE version. So what we did was added those attributes through these platform deploy scripts or the platform, meaning the iOS platform, for example, script. And it was modified heavily so that we could build, check, compile before moving on to the next stage. The last bit about OS and Xcode version upgrades, so we really didn't have to do much there. With subsequent versions, Unreal kind of sorted the stuff on its own. There were small things to be done, but nothing of importance or nothing that took us too long to do. We did have some anxious moments when our Apple TVs got updated automatically to the next OS version while we were merging stuff. But yeah, like I said, nothing out of the ordinary. We just had to move our Xcode up quicker than we had planned, and then it got working. So one very important bit that we learned in this entire upgrade process is how to effectively use the intermediate folder that Unreal creates. When it comes to saving space or making sure that you have the newest projects, that is usually the first folder that gets nuked by everybody. But it's also very helpful, particularly in case of Apple Arcade, because the build and the IDE that Apple uses, Xcode. It cannot, it usually, or it might not be straightforward for people who come from, say, a Visual C++ background to get into. So just a few things about the intermediate folder. It is a really good place to study how Unreal builds the projects. So that is where intermediate files are created. As the name suggests, that is where files are copied from and to the source folder. So it's a good place to see how Xcode's intermediate files like the plist files, which are value key pairs, but very important for overall binary structure of the project, how they get established, how they are copied over. And there is a intermediate directory for every platform, so it would be different for iOS, tvOS, and macOS in this case. So you can just go on full experimentation and actually figure out what needs to be there or how stuff gets from one place to other. I mentioned about the plist files already, but it is, again, the plist files that you would find in the intermediate folder are a really good diff candidates for plist files that you would find, say, in the intermediate folder of vanilla UE4. So if you can simply compare and make out what's missing from a submission point of view or from the Apple, from your game's capability point of view, and make sure that you update it, and it should just take care of itself. So I'm continuing to use Bond mentions here. This was another thing which made it really easy for us. So UE4's source folder layout, right? It's very consistent. You can look it up and plan accordingly. This also gave us a lot of confidence while we were merging stuff. We didn't miss out on things. And it also gave us really good places to put our custom changes in. So for example, for something like an iOS online interface subsystem, we figured that putting it in the Apple folder where we could have it initialized for macOS, tvOS, and iOS instead of having that separately, that really saved a lot of time and makes it easy for us to maintain this stuff across versions as we go forward. Documentation, so epic documentation about iOS and general Apple Arcade development process is a good starter. We also maintained our own internal documentation within Sumo. So that really was a, so this helped because this was all happening during the pandemic. Everybody was working from home. So having centralized documentation really got us to go through. And in terms of the Sumo knowledge pool, this was again a lifesaver. We had some of our best Unreal programmers in Sumo India looking over the entire merge process and the update process. And there was a very sticky issue that I'll come to next, where we even got our UK counterparts involved to take the process forward. And like I mentioned, Apple app development experience always comes handy when you are targeting something like an Apple Arcade. If you know your way around Xcode, it is a lot more easy system to follow when you want to submit your binaries to the respective app stores and track how your app is doing generally. And this is, by this time we had Spyder compiling across iOS, tvOS, and macOS. But yeah, things never go to plan. So the first thing that artists noticed was the lighting was broken. All the maps that we had on Spyder in Unreal, the lighting was totally broken. Shadows were off. Ambient occlusion did not work properly. Bakes were broken. So we figured this out, and I'll explain more about that in the top 5 issues that we had to fix. And it was mainly down to modifying attributes. After we found the fix, it was mainly down to modifying light attributes, which were new to 4.26. Shadows and artifacts, it was a very iterative process between artists, baking lights, identifying what was out of place, and then doing it again. This was important because Spyder is kind of known for its lighting and the overall retro feel that it brings. And 4.26 also got us some really cool advantages when it came to the overall look and feel of the game. So the image on the left is original 4.23 submission that we made to Apple Arcade. The one on the right is with 4.26. So clearly the blue tint of the window is a lot more prominent in 4.26, making it a lot more realistic. The metal cylinder at just below the window, that also looks a lot better with 4.26 against the 4.23 original. The second bit, after the compilations were working, after the app was working, and we fixed lighting, customized build systems really helped us a lot. These were mainly Jenkins jobs on Mac Minis, a couple of iMacs even, and they drove our per platform build. So we could have iOS builds at will, Mac OS builds at will, and tvOS builds at will. And time spent to enable Xcode Live Debugger, that was a lifesaver. Again, I'll explain more about that. Another part of the strategy that we decided early on was the order of submissions that we were going to target. And the hardware capabilities of Apple Arcade platforms helped us a lot there. What I mean by that is we decided to start with Mac Minis and iMacs, because in terms of hardware, they are like the most capable platform. We would then go to iOS, which is like the second rung in terms of hardware capability. And in Unreal parlance, tvOS is nothing but iOS minimized. That is the thought that we had. And yeah, it wasn't as easy as that, as I will come to that. So yeah, by this time, like I said, we had compiling versions of all the platforms, and we decided to start with submissions, which was Mac OS first. So the top 5 issues that we had to face and how we fixed them after the upgrades. First, like I mentioned briefly on the last slide, is lighting. So lighting was broken, and the reason for that, one of the reasons for that was that LightMask, which we used for 4.23, it was the GPU version of LightMask that we used on 4.23. By 4.26, Epic had moved on to a CPU-based light baking LightMask, which helped with light baking, and it had a lot of good features. So what we had to do was, again, go back to our source, take out GPU-based light baking that we had for 4.23, enable CPU-based light baking, and then bake again. Ambient occlusion had to be enabled for all the mobile devices. So on 4.23, that was not the case. But we observed that with 4.26, we could push the hardware more and enable ambient occlusion even on, say, a tvOS, which was unheard of before. So that helped us. Another thing that really helped us on the lighting part, because lighting took most of our time fixing, in terms of fixing issues, lighting was our the most significant issue. Unreal's Swarm agent also helped us big time. Swarm, if you guys don't know, is the distributed light baking solution that Unreal has. It works really well. And for platform like an Apple Arcade, it is a godsend, because building it even on a Mac Mini can take a lot of time. But if you use Unreal Swarm, for example, you can distribute it across a set of Mac Minis, iMacs even, and then it gets baked properly. So Art had to iterate over production bakes, debug bakes if they wanted, fix shadows, and then the lighting was in a place where we thought it was visually as good as the 4.23 version. Next one was a funny one, black screen on tvOS. So we finished submitting on iOS, all was good. And then we fire our tvOS build, and all that we see is a black screen. There is audio running in the background. We can hear UI audio events. We can make out that Spyder is moving in the background, but all that we can see is a black screen. We went through comparing all our INI settings in Unreal, what has changed between 4.23, 4.26, couldn't figure it out. And that's where the ability to live debug with Xcode really helped us. We could go down to ticks and updates, and we ultimately, along with our Sheffield colleagues who helped us, because this was a graphics issue, helped us isolate that this was due to a change to the present spacing setting in Unreal. So once we knew that, then it was just a matter of toggling that setting and making sure that stuff worked on tvOS. Game was visible. Yeah, and we were very happy. Third issue also has to do with tvOS, because tvOS is a special case for Apple Arcade. So unlike iOS and macOS, where you have keyboard, mice, or in case of iOS, it is directly touch, the tvOS builds for Apple Arcade. They support Siri Remote, the second image in white. So that is the input controller for your Apple Arcade experience on tvOS. So when we went on to 4.26, Siri Remote just refused to work. Only the two menu keys were working. Again, comparing merges, looking at what was going wrong, we found out that in 4.23, the input mapping functions for Siri Remote were actually macros, but in 4.26, they were upgraded to be functions, which made more sense. But obviously, our merge had taken both the macros and the functions. So we had to take out the macros, and that solved it. Fourth one is UI anchoring. So I mentioned iPhone 14 while I was explaining things. So iPhone 14 has something called the dynamic island, which is right in the middle of the screen. And it's a new thing, meaning it was never seen before. So when that came in, many of our UI screens had issues of overlapping. So buttons would overlap with the dynamic island, and that meant compliance was not met. So the anchoring dialog at the right extreme is, I'm sure guys who use Unreal would know it is how to use it and what it stands for. So we use that heavily for all the UI elements which needed readjusting. And the good thing about safe area widgets and the anchoring widgets is once you set it up for one particular aspect ratio, it usually works for all the resolutions that are covered by that aspect ratio. So yeah, that was another good learning. And the last one about splash screen compliance is something actually out of Unreal. So with the latest set of, with the latest set of compliance requirements, Apple has specified that every Apple Arcade game at an app level needs to be launched with something that is called a storyboard in Xcode. So we submitted to Apple, and then they came back to us and said, yeah, this requirement has not been met. So what's involved here is in the Xcode project that Unreal generates for you, there is an interface section where you need to add a storyboard and then hook it up to segue into the actual game that launches after the splash screen is saved. So splash screen for game engines for us is just putting it up in the game engine splash screen setting and it should show up. But this is again an Apple special which we had to figure out. So any Xcode development experience is going to take you a long way in Apple Arcade, save you a lot of time at least. So this slide is about our testing and QA process because, like I said, Apple Arcade is a very demanding platform in terms of compliance. We started with Mac for the hardware reason, then went on to iOS, and finally on to Apple TV. And some of the things we stuck with throughout these three submissions, and that kind of helped us. So input, we prioritize. So Apple Arcade devices need to support controllers, external controllers, along with their native input. So what we started was we would do the native input first. So for example, on Mac OS, we would always start with keyboard and mouse and then go on to the controllers. In case of iOS, it will be the touch input, fix any issues with touch input, and then go on to the external controllers. And same for Apple TV, where you fix all Siri input issues first and then go on to the next controllers. Our engine modifications to something like a player setting, a player input or input settings helped us a lot, where we modified the classes to be available to us in terms of the methods like massage input to be available to us in extension, so we could have really custom stuff going on there. Then the next bit is the cross-platform consideration that every Apple Arcade game needs to stick to. Cloud saves, leaderboards, and achievements, these were all aware our priorities. We tested them. So you play the game on tvOS, save it, then launch it on iOS, and make sure that it works. And then you launch the same game on Mac OS, and then it has to start from there. So that was a big one in terms of compliance. All these things ultimately added up to save us time. We got better with every submission, and we could be predictable about, okay, now it has gone to Apple, when can we expect a first reply and what might be the issues that could come our way. Test flight on Xcode is a big time saver. It works for iOS and macOS, or tvOS. So what you do is you create a build. It has to be a shipping build. And then everybody in your organization with a registered device into the development profile, can just download it at will and check. So test flight saved us a lot of time. The final bit was important to make sure that we progressed or we got better over time. So along with the internal test cases that we had to cover functionality and overall game structure, we also kept in tandem with latest and greatest Apple submission requirements, compliance requirements, and updated our test cases accordingly. This, like I said, again helped us with predictably planning our submissions and making sure that there were very few feedbacks and complaints from Apple as to things to be fixed in the release. So yeah, after going through all this process, Spyder is compliant for latest Apple Arcade guidance. My bad. Spyder is compliant on Apple Arcade, on the tvOS, on iOS and macOS. And having a tool like Unreal and then following a process like this really helped us in this journey. So thank you for your time. Questions?
These terms are very, very ambiguous. Who is a artist and who is a game developer? Is somebody who does the lighting in a game or who does these simulations like fire, water, fracturing, is he a developer or an artist?
So again, this is my opinion. I could be wrong. But the process of making games is what games development is, right? An artist, a game artist, is somebody like you mentioned, is somebody who creates art, be it models, visual effects, or lighting.
So a developer is somebody who does the coding, the controls of it.
It's used interchangeably. No more questions? So I'll be, sorry. Sorry.
Can you just brief more about how do you go about debugging in Xcode?
What do you mean by how?
Meaning I come from a Unity background,
Yeah.
so I actually build games and then I
Okay.
find it very difficult actually
Yeah.
getting
Yeah.
the debugs on Xcode.
Cool. So the export process in Unreal, right? How it works is when you export the binary, it starts by actually creating Unreal creates an Xcode project for you,
Yeah.
and then it has everything that your game would have. So when you run the game, and so technically you have all the source code on the Xcode side, and if you know what tick or what method you need to debug into, you can straight away go and put breakpoints and check.
Okay, like write in the Xcode or we do?
In Xcode,
In
in Xcode, yeah.
Got it. So you also mentioned about some Xcode live debugging. So it's this
Xcode.
live debugging in one of
Yeah,
your
that's
slides.
what I meant.
So that's what this
So
is.
you run the game in Xcode, and you put a breakpoint where you think the problem could be, or the area that you need to look at, because you would know the engine, as a programmer at least, you would know where to keep the debug breakpoints, and then it goes there. You can debug,
Okay, thanks.
and you can do that with Xcode for Apple Arcade.
Okay.